Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which converts a binary tree into a threaded binary tree. First, let us take an example. In a simple threaded binary tree, the null right pointers are used to store the in-order successor. Wherever a right pointer is null, it is used to store the in-order successor. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We call the createThreaded function with root, so root points to 1. We will be using a queue to store the in-order traversal. We call the populateQueue function with root and queue. As root is not null, we check if root has a left child. As it is true, we call the populate function with the left child of 1. So now root will point to 2. Again, as root is not null, we pass the left child of 2, which is 4. Hence, root will point to 4. Again, root is not null, but 4 does not have a left child. So, we enqueue 4 into the queue. As node 4 does not have a right child as well, we finish execution for node 4 and return to the previous call. Now we enqueue 2 into the queue. Also, we call for the right child of 2, which is 5. So, root points to 5. As node 5 does not have a left child, we enqueue 5 into the queue. Also, as right child of 5 does not exist, we return to the previous call. We finish execution for node 2 and resume execution for node 1. Now we enqueue 1 into the queue. Next, we call for the right child of 1, which is 3. Hence, root will point to 3. As the left child of 3 is not null, we call for the left child of 3, which is 6. Since node 6 does not have a left child, we push 6 into the queue. Now, as node 6 does not have a right child, we finish execution for node 6. Now we push 3 into the queue. Next, we pass the right child of 3, which is 7. Hence, root will point to 7. As the left child of 7 does not exist, we push 7 into the queue. Also, the right child of 7 does not exist, and hence we finish execution for nodes 3 and 7. Also, execution for node 1 is over. We have the final in-order traversal of this binary tree stored in the queue. Now, we return to the createThreadedUtil function and call the createThreadedUtil function with root and queue passed as parameter. Now, as root is not null and left child of 1 exists, we call for the left child of 1, which is 2. As root is not null, we further pass the left child of 2, which is 4. Since 4 does not have a left child, we pop 4 from the queue. Now we check if 4 has a right child or not. As it is false again, we go to the else part and now set root's right to the front element in the queue. So 4's right will point to 2. Also, we make isThreaded for node 4 to true. We finish execution for node 4. Now we pop 2 from the queue. As 2 has a right child, we pass the right child, which is 5. Hence, root will point to 5. As the left child of 5 does not exist, we pop 5 from the queue. Also, the right child does not exist and we go to the else part. Now we link root's right to the front element of the queue and make isThreaded for 5 true. We finish execution for node 5. Also, execution for node 2 is over. Now we pop 1 from the queue. As node 1 has a right child, we pass the right child. Hence, root will now point to 3, which is the right child of 1. Since root is not null and node 3 has a left child, we pass the left child of 3, which is 6. Since node 6 does not have a left child, we dequeue from the queue. As node 6 does not have a right child, we go to the else part and link 6 right to 3. We finish execution for node 6. Execution for node 3 is resumed and now 3 will be popped. As 3 has a right child, we pass the right child of 3, which is 7. Hence, root will point to 7. As node 7 does not have a left child, we pop 7 from the queue. Since node 7 does not have a right child as well, we go to the else part. Now, since the queue is empty, so we don't link 7 and execution for node 7 is over. Execution for node 3 as well as node 1 is also over. We have the final threaded binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.